Our math lesson today is going to be on comparing and ordering fractions. We've learned about what fractions are and what makes a fraction what it is. But to start with, how many of you have a bicycle? If you have a bicycle, raise your hand. Everybody in here has a bicycle. All right, put your hands down. How many of you know what the part of the bicycle that your tire goes on is called? The little... You may know what they're called, the little things. The chain helps control your bicycles. Anybody? Spokes. Good. So the spokes in your bicycle are in the center of your bicycle. If I were to draw a bicycle tire up here, this would be kind of your tire, and your spokes are going to be in the middle. So we're going to watch a short little video about, it's a real world video, so this is about building bicycles.
Please welcome the breakaway group here coming down onto the straightaway. 6 to go. 6 laps to go. 6 laps to go. Rabobank at the front. Presumably in service of Oscar Freire.
Equal tone means equal tension. You have to make sure that all the spokes are working together to make a wheel that is A, strong, and B, stays straight. The tone from the spokes is actually going to be transmitted through the stand into the headphones. So they're actually going to listen to every single spoke as they go around the wheel to make sure that it's got equal tone. That's the main key difference between a person building the wheel and a machine building the wheel.
Alright, so that was just a short little video about building bicycle wheels. Notice he kept hitting the spokes on the wheel. He was listening for the tone, the sound that it makes. Because the wheel, the spokes, need to make the same sound. They have to have the same tension to be a good bicycle wheel or good spokes for the tire to go on. It needs to have good tension, but they all have to be equal tension. So that was just a little video to kind of get us start thinking. Now, our first question today is on the bicycle, and we're again looking at comparing and ordering fractions. Our essential question is, how can you compare and order fractions? We know what fractions are, and you know how to decide if one fraction is bigger than the other one. But it's talking about how can you compare and order them if you had like 3 fractions or 4 fractions. So that's what we're going to be looking at. And again, the first question starts off by talking about a bicycle. Look at your paper while I read it out loud. Harrison, Tad, and Dale ride their bikes to school. Harrison rides 3/4 of a mile, Tad rides 3/8 of a mile, and Dale rides 3/6 of a mile. Compare and order the distances the boys ride from least to greatest. If we're writing them from least to greatest, that's from the what? Smallest to the biggest. Alright? It says circle the fractions you need to use. What do we need to circle?
3/4, 3/8, and 3/6.
Okay, good. 3/4, 3/8, and 3/6, because those are our 3 fractions. Now it says underline the sentence that tells you what you need to do. What are we trying to do? Which sentence tells us what to do?
Compare and order the boys ride.
Good. Compare and order the distances the boys ride from least to greatest. So we underline that. Now, to help us out on activity 1, they have provided some fraction strips for us. Notice that they are giving you a fraction strip, and they have the unit fractions listed in each one of the fraction bars. This represents one whole. Now, we know that Harrison rode 3/4 of a mile, so how can we show that on this fraction strip?
Oh, that's shaded.
Color 3 of the 4. So get your colored pencil or crayon, and you're going to color in 3 of the 4 to represent 3/4. Now, Tad rides 3/8 of a mile. So how do I need to represent 3/8 of a mile?
Color 3 of the 8.
Color 3 of the 8. It doesn't matter either one. And the last one, Dell rides 3/6 of a mile. So I need to color
3 of the 6.
3 of the 6. Now, notice something. What did you notice about when we shaded these?
We all colored 3 out of our.
Good. We colored 3 out of all of them. But did they end at the same point?
No.
No. Each unit fraction is a different size, isn't it? 1/6, 1/8, and 1/4, they're not the same size, are they? If we look at 1/4, 1/8, and 1/6, which one of those is the biggest? 1/4. Which one's the smallest?
1/8.
1/8. So it says which is the longest unit fraction? We said the longest or the biggest was 1/4, and the shortest unit fraction was 1/8. Remember, to be a unit fraction, it has to have 1 as its numerator. It's got to be the number at the top. Now that we know our unit fractions, let's look at when we shaded 3. Which one of it says, are the shaded fourths still the longest? If I shade 3/4 and I shade 3/8 and 3/6, every time I add a fourth, am I still adding a longer amount? Yes, because each fourth piece is what? Bigger than all the other pieces. So it says, are the shaded fourths still the longest? Yes, they are. Because each time I add it on, it's still going to be longer. Are the shaded 8 still going to be the shortest every time I add it? Yes, because they are the smallest. And it's just asking us that again. Are the shaded fourths the longest, or are the shaded 8s the shortest? Now, at the bottom it says 3/4 of a mile is the blank distance. Alright, let's look up here. The more pieces a hole is divided into, the smaller the piece, and the fewer pieces a hole is divided into, the bigger the piece. So which one of these is the longest? 1/4, and which one of the shaded ones is the longest? No, you were right. It's 1/4, but how many did we shade? 3. So if this is 3/4, and this is 3/8, and this is 3/6, which one's the longest? 3/4. So 3/4 of a mile is the blank distance. Longest, shortest? Longest. Good. And 3/8 is going to be the shortest. And of course, 3/6 is going to fall in between those two. And that's what it told us at the bottom. It falls between those two distances. The middle. Now, it said, so the distance in order from least to greatest are blank. So it's wanting us to go from the smallest fraction to the biggest. So what was the smallest fraction?
1/8.
Smallest. You're right, would be 3/8. What would be next?
3/6.
3/6, and then what was the biggest?
3/4.
3/4. So if I were to ask you to list those fractions in order from the least or the smallest to the greatest or the biggest, you would say 3/8, 3/6, and 3/4. When you've got that filled in, turn to the back so I know you're ready to move on. Are you ready? Alright, on the back at the top, it says, order 2/6, 2/3, and 2/4 from greatest to least. Notice they've changed now. They want it from greatest to least, which means they want it from the biggest to the smallest. Order the fractions by thinking about the length of the unit fraction strip. Then label the fractions shortest, between, or longest. Alright, a unit fraction we know has 1 as its numerator. So if our fraction is 2/6, our unit fraction is going to be 1/6. Good. If our fraction is 2/3, our unit fraction is
1/3.
1/3. And if our fraction is 2/4, our unit fraction is 1/4. Now, we have 1/6, 1/3, and 1/4. That's like saying we take a pie and we divide it into 6 pieces, 3 pieces, and 4 pieces. Which one of those is going to be the smallest?
1/6.
Oh, hang on just a minute. You've caught all 3 answers. I want you to be able to justify to me why that answer is or is not correct. So let's talk about it. 1/6. How many pieces did you say this would be in? 6. And if I take that same pie and I divide it into 3 pieces, which one's going to have the bigger pieces?
1/3.
1/3. Why?
Because it has the smallest.
Because there's only 3 pieces, right? If I took a pie and I divide it into 3 pieces, and I take the same pie and I divide it into 6 pieces, sorry, those are not very equal. I'm going to have more pieces here, though. So that's what you've got to understand. Remember, that's what we've been talking about. The smaller number means that they're bigger pieces. So, with that being said, the bigger number is going to be the smaller pieces. So they want us to label shortest, between, and longest. So if this is the smallest pieces, or the smallest unit fraction, it's also going to be the shortest. Now, we have 1/3 left and we have 1/4. If I take it and I divide it into 3 pieces and I divide it into 4 pieces, which one of those is going to have the bigger pieces?
1/3.
The 1/3, because there's only going to be 3 of them. So if that is the biggest unit fraction, that's going to be the longest length. Good. And then, of course, the other one would be the between. It says, when the numerators are the same, think about the blank of the piece to compare and order the fractions. We've been thinking about the what of the piece? Alright, but it's saying when the numerators are the same, think about the blank of the piece to compare and order the fractions. We're thinking about the what of the piece? Does that make sense? When the numerators are the same, think about the blank of the pieces to compare and order fractions. We're trying to think about the... If I'm trying to compare them, I have to think about how big each one is. So I'm thinking about, or how small it is. So I'm thinking about the... Don't call out something that doesn't. Think about it. When the numerators are the same, think about the blank of the pieces to compare and order fractions. If you're comparing how big it is or how little it is, you're comparing its size. When the numerators are the same, think about the size of the pieces to compare and order the fractions. Okay, so order the fractions from greatest to least. Our greatest to least is going to be the same as the longest to the shortest. So what was the longest?
1/3.
1/3, but we've actually got to list the fraction, so it is 2/3. What was the between?
1/4.
1/4, so we've got to list the fraction though, which is 2/4. And then the shortest was,
1/6.
and we've got to write the fraction 2/6. Remember, when you're comparing these fractions that have the same numerator, that top number's the same, you've got to look at the denominator. And the bigger the number, the smaller the piece. The smaller the number, the bigger the piece. Don't forget that. Alright, now we're going to change a little bit. Activity 2 is a little different. Activity 2, we're looking at fractions that have the same denominator. That means that they're all broken into the same amount. For instance, we have 5/8, 8/8, and 3/8. All of them are divided into the unit fraction 1/8 because they all have the same denominator. They're all broken into the same number of pieces. So with that being said, they want us to figure out what these fractions are from the least to the greatest. So with your colored pencil, you're going to shade 5/8, 8/8, and 3/8. So to shade 5/8, how many do I need to shade? 5. To shade 8/8, how many do I need to shade? All of them, which is 8. And to shade 3/8, how many do I have to shade?
3.
Of the 8. Alright, when the denominators are the same, the size of the pieces is the, when all of them are the same, the size of the pieces are the, when the denominators, don't say it, think. When the denominators are the same, the size of the pieces is the, you're making this a whole lot harder than it is.
Same.
Thank you, Nico. Say that for us.
Same.
Same. When the denominators are the same, the size of the pieces are the, or is the same. Y'all are making that a whole lot harder than it is. It's not asking for numerator, it's not asking for denominator. It's not asking for longest, shortest. It's just asking a simple question. When the denominators are the same, the size of the pieces are the same. So think about the size of the pieces, again, to compare and order the fractions. Which one is the shortest?
1/8.
They're all 1/8. So you got to look at, we've got 5/8, 8/8, and 3/8. Which is the shortest?
3/8.
Okay? 3/8 is the shortest. Which is the longest?
8/8.
8/8. Which is the longest, and which one's in between?
5/8.
5/8. So if I were to put them in order from the least to the greatest, or from the shortest to the longest, what would come first?
3/8.
3/8,
5/8.
5/8,
And then 8/8.
and then 8/8. I will say it's often easier when the denominators are the same versus the numerators the same. Because when you've got the numerator the same, you've got to really pay attention to your numbers because everything's the opposite on the bottom. But when your denominator's the same, it's pretty easy because your numbers are in order at the top. Alright, go ahead and look at 1 through 3. I want you to answer 1 through 3 on your own, and then I'm coming around to check it. Just leave 4 of them. Right, then you would put it in about 4/8 is the shortest. Yeah. Just like that. When you get to this one, your other fraction is 6/3. If you want to write it up there beside it. It's got to be like 4, 6, 4, 4. You got it 20 years off that way. Right here, you did this one twice. Look at that. You used the same fraction twice. Right here. How many did you shave? So that's what your... Look, these are your 3 fractions. When your numerator's the same, it's you're going from least to greatest. So when your numerator's the same, it's going to be from the biggest number to the see what I'm saying? Go by your picture. Good. Alright, and then denominator's the same, you're going from least to greatest. If you need to, you can draw the picture. If it'll help you draw the pictures, or you can take out your math board and draw the picture, you take all the way to number 3. This one your denominator, this one your numerator. So when you put your numerator is the stuff. This one? Because look, your numerator's the same. Alright, look right here. You've got 4/8, 4/4, 4/6. Here's 4/4. You're saying it's less than that? You see what I'm saying? This one asks you to go from least to greatest. You did the opposite. It's going from the smallest to the biggest. Alright. 1/6. Okay, you drew these pictures right, but it said from least to greatest. That was your smallest piece, which was actually, you see what I'm saying? Your pictures are very helpful. Okay, look right here. This one is not like this one. This one your denominators are the same, so you just have to look at the top. But this one your numerators, so remember the numerators are the same, it's the opposite. Right. Yes, you still didn't answer that one. Let me see. This one is beautiful from least to greatest. How is 4/4 for sure? Just stuff like that. And right here, this one's right, and the denominator is the same, and the numerator is the same. You have to do that. Just wait for you to check it. Alright, but right here, which one of those did you shade the most of? So that one should be, if it's least to greatest, then that should be your last number. Yeah, but if you do that, that's not how you draw it, so don't worry about that. Alright, look right here. Your three fractions are right here. Those are not your fraction. And remember, when the numerators are the same, it's the opposite. The biggest number should be the smallest. Yes, ma'am. Alright, well, it's same thing here, it was the same. To go from least to greatest, you had to go from the biggest to the smallest. So to go from greatest to least, you're going to have to do it from the smallest to the only because they're the same. You're correct. Good. There you go. Now, same thing here. The numerator's the same, so it's the opposite. The numerator's the same, so actually go from the biggest number to the good. Good. Yes. Alright, this is my one right here. They're in order from least to greatest, from the smallest to the biggest. You did the opposite. See, 4/4 was the most. You did the opposite. Okay, do this one just like you did that one. If the numerator's the same, then you've got to do the opposite, because remember the pieces are different. So you're actually going to have to go from the biggest piece to the smallest piece. Mm-hmm. Good. Does that make sense now that you drew it? That drawing, those drawings are helpful. Okay, when they're the same, you're putting them in order from the smallest to the biggest. So what would the smallest be? Mm-hmm. Is that what that says? You would put exactly what they did. That's not what you told me. Alright, what would be next? Mm-hmm. What would be next? Mm-hmm. Now, this one's the opposite, because look, now it's the numerator. So you've actually got to go from the biggest number to the smallest number. So what would the biggest number be? Mm-hmm. When you're finished, you can take out your math board and work facts on it. Just practice some of your multiplication facts. Good. Good. Yes, you can take out your board and work on your math. You stop it and do it. That's right. That's right. Now, look right here. You have to do it all. So you did all the magic the same. You just put a little from the smallest one to the biggest one. That's what it says. And then you bring this and do the opposite. So that's right. But look right here. So if you did all the magic the same, you just put the order so we can do the smallest. Zero. Good. So put those in order. Alright, this one right here. And the denominators, and you just have to put the numbers. You mean from least to greatest, so the smallest to largest is the smallest. 1, 0, 2 is the smallest. It's the smallest. A 1, a 0, or a 2. A 0. Alright, so put that one first. Then which one will be next? Mm-hmm. And then which one will be wrong? Alright, now on this one, it's the numerator, so it's the opposite. So you do the opposite, so you're actually going to go from the biggest number to the smallest. What's the biggest number? Tell me your numbers. So do that one, and then the next one. sure you look on 4 through 7, it's greatest to least, and on 8 and 9, it's least to greatest. Good. Good. Now look right here. This one's the least to greatest, so which one of these has the least amount shaded? Alright, so that one will be your first one. So just bump those up here. Good.
Yeah, it's sort of in my crayon, but I can't do it very good.
It's okay.
I was trying to prevent it one more. And that one will be the same way because it's the bottom numbers. So it'd be 2 and 4X. Mm-hmm. That's from least to greatest. The bottom number is the same from least to greatest. Make sure when you're looking at these again, let me stress to you, when you're looking at these are least to greatest, these are greatest to least. So make sure you're looking at that. When we finish. Do the 8s too. That's right. That's right. Look at that. Look at that.
4, put your boards away for the moment. While we check our work, put them away for just a minute. Alright, looking at number 4, the denominators are the same, so we just have to look at our numerator. It says from greatest to least, so we're going from the biggest number to the smallest number. So what's the biggest number?
6.
Or the biggest fraction? Good. Is 6. Oh, I'm in orange. 6. I don't think y'all will be able to see it. Alright, what comes next?
5, 6.
5, 6, and what's last?
2,
2, 6. Now, this one, all the numerators are the same, so we've got to think the opposite. The bigger the number, the smaller the piece. So since we're going from greatest to least, we actually need to find the smallest number. So what's the smallest?
2.
2, which would be 1/2. What would be next?
4.
1/4, and then
1/8.
1/8. Alright, our numerators are the same, so same thing again. We're looking for the smallest. What was the smallest?
0 4.
It wasn't a 0. Look at number 6. I think you're on the wrong one. Okay, we have 3 6, 3/4, and 3/1. So what would be our smallest?
3
Okay? What would be next? 3/4, and what would be last? 3 6. Alright, here our denominators are the same, so we just look at the top number. Which one is the biggest?
5
5/8. What's next?
3 8.
3/8, and what's last?
1 8.
1/8. Check your answers. Now they swapped on us. Now we're least to greatest. So our denominators are the same, so we just look at the top number. What's the smallest one? 0/4. What's next?
2 4.
2/4 and
3/4.
3/4. Alright, our numerators are the same, so I've got to look at the denominator. We're thinking the opposite of what it normally is, so we need to go from the biggest number to the smallest number. What's the biggest number? 2 8. What's next? 2 6 and 2 4. Here, our numerators are the same, so again, we're doing the opposite of what we're thinking. We're thinking from the biggest to the smallest. What's the biggest? 6 8. What's next?
6 thirds.
Thirds, and what's last?
6
6 halves. And the last one, the denominators are the same, so we just have to look at the top number. From the smallest to the largest, what's the smallest? What's the smallest?
2 halves.
2 halves. You're the smallest, baby. That's what I was telling you to look back at that one. The smallest, which of 4, 2, and 8, which is the smallest? Of those three numbers, which is the smallest? 4, 2, and 8. What's the smallest number? Is the smallest? Of 4, 2, and 8, what's the smallest number? If I had these three numbers, which is the smallest number?
2.
So that would be the smallest fraction. Alright, what's next? 4 halves, and what's last? 8 halves. Check your answers. When you've checked those, turn to the back. Alright, on the back, number 12. Number 12 says in 15 minutes, Greg's sailboat went 3/6 of a mile, Gina's sailboat went 6/6 of a mile, and Stuart's sailboat went 4/6 of a mile. Whose sailboat went the longest distance in 15 minutes? Decide which one of those is the largest fraction. Don't say it out loud, you decide. Looking at your paper. We're comparing 3/6, 6/6, and 4/6. Which of those is the biggest fraction?
6.
All right, good. 6-6. And the question says whose sailboat? So whose sailboat went 6-6? Let's go back to it. Gina's went 6-6. So whose sailboat? Gina's sailboat.
They should all call it something.
All right, whose sailboat went the shortest? If Gina's is the longest or the biggest, what's the smallest?
Greg's.
3-6 and 4-6, which one's smallest?
Greg's.
But which one of 3-6 and 4-6? 3-6, and then go back to your question and find 3-6 was Greg, so Greg's sailboat. Listen for what my question is. Y'all aren't listening. Number 13 says pose a problem. Look back at exercise 12. Write a similar problem by changing the fraction of a mile each sailboat traveled so that the answers are different from exercise 12. So you're writing a problem similar to this. It can be the same idea. They just want you to change the 3 fractions to something different. Go ahead and do that on your paper.
So we have to write.
One similar to that, but you need to change the fractions. You can pick the 3 fractions. On number 12? Oh, like can you? Yes, you can change. Write it though as a word problem. Those can be your 3 fractions, but write it as a word problem. Inserting your fractions into it. when you're finished with that, look at number 14 and start reading it. Oh, yes, this is very reasonable. If you answer number 14, you can also answer number 15. It would be between. It does. Alright, look at number 14. Tom has 3 pieces of wood. The length of the longest piece is 3/4 of a foot. The length of the shortest piece is 3/8 of a foot. What might be the length of the third piece? If we have the longest piece and the shortest piece, we're trying to find the piece that would be in the middle. So what would be in between 3/4 and 3/8? Okay, that's an option. 3/6, 3/5, 3/7. I think those are the only 3. Anything else would either be smaller or larger. We got to get right here in this part between the 2. If you haven't already done so, read number 15 and answer it. You're putting the 3 fractions in order from the least to the greatest. They have the same numerator, so you got to look at the denominator and think the Alright, check your answer. Alright, listen carefully. For right now, before we do our next activity, I want you to tear out page P183. P183 out of your homework book. And then we'll start our next activity.